Okay, so we're given a problem here. It's hyperbola, and they're asking for the foci, center, and asymptotes of it. Let's go through it. Looks like a relatively simple question. I would divide both sides by 20. You would get x squared. When I divide the first term by 20, 5 goes in 24 times, minus 5 and 24. This is weird looking, isn't it? Then it's going to be 4y squared. Again, I'm dividing by 20, and that equals 1. I got to write this in the form I like to write it in. I'll put this down for you. X squared over 4 minus y squared. That's 1/4. And that equals the number 1. All right, so the first thing I would do, and again, you might be different about this, is kind of visualize the problem. Again, I'm not saying my picture is going to be great. I will look at probably a better graph later. But right now, the center is here. I'll write that down, center. And the center's a point, the point 0, 0. The next thing I'll do is I'll put the vertices down. And again, are they asking for these things? Well, they asked for the center, and they asked for the vertices. Let's write that down. What's that going to be? Well, I'm going to set the y to be 0, and the x would be plus or minus 2. All right, so let's put that down. And I'll just, ballpark it. So that's 2 there, minus 2 there. All right, that's done. Let's do the foci. How do I do that? Well, I write down c squared. I'm going to take the number 4 and add it to the number 1/4. What do you get here? Column number 4. 4 times 4 is 16. 16 plus 1 is 17. So what do you get over here? C squared is 17/4. And the C is going to be plus or minus. Maybe I shouldn't put that down. I don't really need to do that. The C is going to be the root 17 over 2. So what you have to do for the foci is move in from the center. Relatively simple to do. And I'm moving in root 17 over 2. So what are you going to get? Minus root 17 over 2, comma 0. And the other one's going to be root 17 over 2, comma 0. So I got those, and I don't have the aspects yet, but I get a general idea what they look like. And I want to point out the way I do that. And again, somebody said it's a formula. It's really not a formula. I'm looking at what happens when x and y get really large. And when x and y get really large, they do differ by 1, by the way. But when they get really large, different by 1 is almost like saying they're identical. So what I'm going to do over here, if they're identical, what I'm really saying is these two terms over here, when x and y get large, would be equal, right? They do differ by 1, by the way, but in their limit, they look like the same thing. So let's write this down over here. And I'm going to write down y squared. I'm looking for the asymptotes now. So y squared over 1/4 is equal to x squared over 4. I'm going to multiply the left and right side by 1/4. And what do you get over here? Y squared equals 1/16 of an x. What do you get there? Y equals plus or minus 1/4 of an x. So the asymptotes, you're going to get y equals, one of them is going to be just x over 4, and the other one's going to be y equals minus x over 4. And again, I'm just going to do a rough picture over here. I know it's not properly scaled, but that doesn't much matter to me at this point. All right, so what do you do now? Look at the key, and suddenly they ask for certain things. What did they ask for? They asked for the center, they asked for the vertices, they asked for the asymptotes. So vertices, foci, center, and the asymptotes. Did I put all that down? Oh, foci over here. Let's grade it. And let's take a look at it. Vertices, got that. Asymptotes, got that. Center, got that. Foci, got that. I also want to point out a much better picture. Certainly I would learn to use technology. If you look at this picture here and this picture over here, although roughly correct, I like the picture a machine produces. You need to learn how to use a machine, though. It isn't like a simple thing to do. When I say that, a machine software, and what software are you using? Whatever you want to use, all right? Whatever you want to use. I'm using Grapher here, though. Thank you.